Airworthiness requirements for structural strength are a crucial aspect of aircraft design and certification. These requirements ensure that the structure of an aircraft is capable of withstanding the loads and stresses experienced during normal and abnormal operating conditions. Here's an overview of the concepts related to structural strength and their classifications. Structural classification. Aircraft structures are typically classified into three categories: primary, secondary, and tertiary. Primary structures. These are the load-bearing structures responsible for supporting the major flight loads. Examples include the main wing spar, fuselage, and tail structure. Failure of primary structures can result in catastrophic consequences. Secondary structures. These structures provide additional support and contribute to the overall strength and integrity of the aircraft. They are not directly responsible for carrying the major flight loads. Examples include fairings, access doors, and non-critical components. Failure of secondary structures may affect aircraft performance but does not usually lead to catastrophic failure. Tertiary structures. These structures are primarily non-load bearing and do not contribute significantly to the overall strength of the aircraft. Examples include interior furnishings, non-structural covers, and decorative elements. Fail-safe concept. The fail-safe concept is a fundamental principle in aircraft design, stating that the structure should be able to sustain damage or failure of a certain component without leading to a catastrophic failure. Fail-safe design involves redundancy, structural reinforcements, and the use of backup systems to ensure that even if a component fails, the overall structure remains intact and the aircraft can still operate safely. Safe life concept. The safe life concept involves determining the fatigue life of critical components and establishing inspection intervals or retirement times based on predicted fatigue crack growth. The goal is to ensure that these components are replaced or inspected before they reach a critical fatigue threshold, thereby maintaining their integrity throughout the expected service life of the aircraft. Damage tolerance concept. The damage tolerance concept recognizes that structures may experience damage during operation, such as cracks, corrosion, or impact damage. This concept involves designing the structure to tolerate a certain level of damage without experiencing a catastrophic failure. Damage tolerance design includes techniques such as redundant load paths, inspection protocols, and repair procedures to manage and mitigate the effects of damage. In order to comply with airworthiness requirements, aircraft manufacturers must demonstrate through extensive testing, analysis, and documentation that their aircraft structures meet the necessary strength and safety standards. Regulatory authorities, such as the Federal Aviation Administration, FAA, in the United States or the European Union Aviation Safety Agency, EASA, in Europe, oversee the certification process and ensure that the aircraft structural strength meets the established criteria for airworthiness and safe operation.